Settle in now, let your breath slow, and allow your mind to drift somewhere vast and quiet and full of ancient wonder. Somewhere between the coast of Florida, the island of Bermuda, and the shores of Puerto Rico, there lies a stretch of sea unlike any other. This region, roughly triangular in shape, has been called by many names over the centuries, but the one that endures is the Bermuda Triangle. For hundreds of years, ships have sailed these waters on their way between continents, carrying cargo, letters, and the quiet hopes of those aboard. And yet, some of those ships simply did not arrive. In 1872, the merchant brigantine Mary Celeste was found drifting in the Atlantic, perfectly intact, her cargo untouched, but every soul aboard had gone. The logbook entries were ordinary, the last written entry unremarkable, as though the crew had simply stepped away for a moment and never returned. In 1918, the USS Cyclops, an enormous Navy collier carrying over 300 men, departed Barbados bound for Baltimore and was never seen again. No distress signal was ever received, no wreckage was ever found, and the sea gave back nothing at all. Slowly, over the decades, the disappearances accumulated, each one a quiet question mark left hanging over the blue. Researchers have counted more than 50 ships lost in this region over the past 5 centuries, though historians continue to weigh each case carefully. The ocean here is deep in places far deeper than most people imagine, with trenches descending several miles below the surface into complete stillness. And so tonight we begin at the beginning, with the sea itself, patient and immense, holding its stories far below where the light can reach. On the afternoon of December 5, 1945, 5 TBM Avenger torpedo bombers lifted gently from the runway of Naval Air Station Fort Lauderdale, Florida. The flight was a routine training exercise, carrying 14 young men into skies that were, at first, calm and clear. Their mission, known as Navigation Problem Number 1, would take them east over the Atlantic, then north, then back to base along a simple triangle. Lieutenant Charles Taylor led the flight, an experienced pilot who had logged hundreds of hours in the air over the Pacific. For the first hour, everything unfolded as expected, the aircraft moving steadily through the afternoon air above the glittering sea. Then, sometime after 3 in the afternoon, radio operators on the ground began receiving fragmented transmissions from Taylor. Taylor reported that his compasses were not working properly, and he was uncertain of his position over the water. He believed, incorrectly, that he was flying over the Florida Keys and turned his flight northeast to find land. In truth, the flight was likely positioned northeast of the Bahamas, and the turn carried them further out into open ocean. As the afternoon deepened into evening, radio contact grew more difficult, the voices becoming quieter and harder to understand. A large Martin Mariner flying boat was dispatched to search for the missing aircraft, carrying 13 crew members of its own. The Mariner vanished as well before it could reach the search area, leaving no trace on the quiet surface of the sea. In the days that followed, one of the largest search operations in naval history combed the Atlantic, yet found nothing of the 5 planes or their crews. Beneath the surface of the Bermuda Triangle lies one of the deepest and least explored regions of the Atlantic Ocean. The seafloor here drops gradually away from the islands of the Bahamas, descending into a vast, quiet plain called the Puerto Rico Trench. At its deepest point, the trench reaches more than 8 kilometers below the surface, the deepest spot in the entire Atlantic. Water pressure at those depths is immense, more than 800 times the pressure felt at sea level on a calm, still day. For centuries, sailors crossing these waters felt only the gentle rise and fall of the swells, unaware of the vast silent world beneath their keels. The seafloor of the Bermuda Triangle region is not one flat plain but a series of slow ridges and quiet valleys formed over millions of years. Thick layers of sand and silt have drifted down over millennia, slowly burying whatever the ocean has kept in its care. Submarine canyons carved gently into the continental shelf near the Bahamas, channels carved by ancient rivers long before the sea rose to cover them. Scientists have mapped these canyons using sonar, and their soft contours tell the story of a landscape that once breathed open air. The warm Gulf Stream flows northward through this region, carrying heat from the tropics and setting a slow rhythm for the waters above. Below the Gulf Stream, the water cools slowly with depth, settling into layers of differing temperatures that scientists call the thermocline. In these cold, quiet depths, the pressure and temperature together slow nearly everything. Sound travels differently, time feels stilled. And so the deep blue void below the Bermuda Triangle rests in its own slow silence, patient and vast and undisturbed. Deep within the Bermuda Triangle, sailors have long noticed something quietly unsettling about their compass needles. A compass needle, under normal skies, rests steadily, pointing faithfully toward the magnetic north. But in certain stretches of the triangle, that needle begins a slow, restless drift, turning without reason. This region is one of the few places on Earth where true north and magnetic north briefly align. Centuries ago, when Christopher Columbus sailed these waters, he recorded the strange behavior of his compass in careful detail. He watched the needle wander at dusk, noting the shift with calm curiosity in his ship's log. The Earth's magnetic field is not a simple, fixed thing. It shifts and breathes across long stretches of time. Beneath the ocean floor, iron-rich rocks carry faint magnetic signatures laid down over millions of quiet years. These ancient formations can nudge a compass needle just slightly, enough to send a careful navigator off course. The Gulf Stream, that vast river of warm water flowing through the triangle, also carries its own quiet magnetic influence. Solar winds, too, press gently against the planet's magnetic envelope, nudging needles in ways no early sailor could explain. Modern researchers have mapped these magnetic anomalies carefully, finding them to be natural, if quietly fascinating, features of this ocean. And so the wandering needle, once a source of wonder, becomes simply another gentle reminder of the living planet beneath us. In the spring of 1918, a large American naval vessel set out across the warm Caribbean Sea, carrying more than 300 souls on board. The USS Cyclops was one of the largest ships in the United States Navy at the time, a massive collier built to carry coal and supplies. She measured nearly 550 feet in length, a quiet giant of the sea, painted in the muted gray of military service. The Cyclops departed the port of Barbados on the 4th of March, heading north through waters that were calm and unremarkable that day. On board were over 300 crew members and passengers, along with a heavy cargo of manganese ore bound for Baltimore. Manganese ore is an extraordinarily dense material, and historians have noted that the ship was loaded beyond her recommended capacity. One of her two engines had already been out of service for some time, slowing the great ship and limiting her options at sea. The commander of the vessel, Lieutenant Commander George Worley, was known as an eccentric man with a difficult and unpredictable temperament. No distress signal was ever received from the Cyclops, and no wreckage, no oil slick, and no survivors were ever found. She simply did not arrive in Baltimore, and the quiet absence of any explanation became one of the greatest maritime mysteries in American history. Several theories have been considered over the decades, including structural failure from the overloaded ore, instability caused by the disabled engine, or a sudden catastrophic shift in cargo. Others have pointed to the turbulent politics of the time, with World War I still ongoing and German submarines active in Atlantic waters. Whatever the explanation, the Cyclops rests somewhere beneath the Atlantic, a quiet reminder of how even the largest vessels are small against the patience of the sea. Beneath the surface of the Bermuda Triangle, where sunlight gradually fades into deep blue stillness, unusual lights have long been observed by sailors and pilots passing overhead. For centuries, mariners crossing these warm Atlantic waters recorded quiet flashes rising from below, gentle and slow, like embers drifting in a vast darkened room. Scientists have spent many careful years studying this part of the ocean, and they have found that the seafloor here holds remarkable geological formations that occasionally release plumes of gas. Methane seeps, rising slowly through thousands of feet of water, can scatter and refract the little available light in ways that appear almost luminous from a distance. The ocean here is also exceptionally warm, and warm water sustains vast colonies of bioluminescent plankton that drift together in quiet, glowing clouds. These microscopic organisms, stirred by the movement of a passing ship or a shift in the current, emit a soft blue-green light that can paint the entire sea surface for miles. Pilots flying low over the triangle at night have described what looked like illuminated roads beneath the water, wide pale corridors stretching calmly into the distance. Researchers now believe many such sightings were ribbons of white sand visible through extraordinarily clear water, lit by moonlight or the glow of the stars above. The Bahamas Bank, sitting just at the northern edge of the triangle, is one of the most optically clear bodies of shallow water anywhere on Earth. In this water, visibility can extend to more than 200 feet, making the sandy ridges and ancient reef structures below appear almost afloat beneath the surface. Early Spanish navigators who crossed these waters wrote in their logs of a strange luminosity rising from below, which they described with quiet wonder rather than fear. That same quiet wonder has followed explorers across many centuries, each generation finding its own careful words for the light that drifts beneath the Bermuda Triangle. The lights beneath these waves are not a mystery so much as a reminder of how alive and quietly radiant the ocean has always been. In the early 1800s, a British merchant vessel called the Ellen Austin sailed quietly through the waters of the North Atlantic. She was a sturdy, well-built schooner, carrying cargo across the open sea on long, uneventful voyages. In the year 1881, somewhere in the western Atlantic, her crew spotted another vessel drifting alone on the water. The ship had no flag flying, no one at the helm, and its sails hung loosely in the still, warm air. The captain of the Ellen Austin decided to bring the derelict vessel alongside and send a small crew aboard to investigate. What they found was a ship in perfectly good condition, with cargo still stored below, provisions in the galley, and nothing out of place. There was simply no sign of the crew, no struggle, no damage, only an eerie, peaceful stillness throughout every cabin and corridor. The captain assigned a prize crew of volunteers to sail the derelict ship alongside the Ellen Austin toward port. For a time, the two vessels moved together through calm seas, the derelict following steadily behind her companion. Then a fog came in slowly, spreading across the water and swallowing the distance between the two ships. When the fog finally lifted, the derelict ship was gone again, drifted off course and vanished from sight. Historians who later examined the story found that records of the Ellen Austin do exist, though the details of the ghost ship encounter are difficult to verify. And so the Ellen Austin drifts on in memory, a quiet story of the sea that asks more questions than it answers. Over the decades, a quiet pattern began to emerge among pilots flying the routes above the Bermuda Triangle. Experienced aviators, calm and methodical by training, would land and describe a peculiar sensation of time simply slipping away. They had followed their instruments carefully, yet something in the air above those waters felt gently, inexplicably different. One well-known account came from a flight instructor who noticed his compass spinning slowly, without explanation, for several quiet minutes. When he landed and checked his watch against the tower clock, nearly 20 minutes seemed to have passed without his awareness. Scientists who later reviewed such reports suggested that unusual atmospheric electromagnetic conditions might gently distort a pilot's sense of duration. The Gulf Stream below carries warm water northward, and the meeting of air masses above it can produce subtle invisible turbulence. In such conditions, pilots have sometimes described a softening of focus, a gentle mental fog that lifted only after they cleared the region. Some researchers have pointed to infrasound, very low-frequency sound waves produced by ocean storms, as a possible quiet contributor. Infrasound at certain frequencies can cause mild disorientation and a dreamlike sense of unreality, even in people who feel entirely calm. These effects are subtle and temporary, like the feeling of a slow tide washing in and then quietly receding. Most pilots who spoke of missing time reported that the sensation passed completely once they were back over familiar land. And so these quiet accounts remain part of the Triangle's story, not as proof of something strange, but as a reminder of how gently mysterious the natural world can be. Beneath the warm, clear waters of the Bermuda Triangle, coral reefs stretch across the seafloor like ancient, silent gardens. Over centuries, countless ships have drifted into these reefs, coming to rest gently among the coral formations. The reefs of the Bahamas and Bermuda together span thousands of square miles of shallow, sheltering water. Coral polyps slowly encrust iron anchors, wooden hulls, and bronze cannons, drawing them quietly into the reef itself. In the shallow waters near the Bahamas, wreck of a Spanish merchant vessel from the 1700s still rests, half buried in coral. Sea fans and brain corals grow slowly over broken masts and scattered timbers, softening every edge with quiet color. Fish move through open cargo holds and empty cabins, treating the wreck as a familiar, peaceful home. Marine archaeologists use sonar and careful diving surveys to map these hidden graveyards beneath the reef. The warm Caribbean current carries nutrients into the reef, sustaining the living colony that quietly surrounds each wreck. Some wrecks are so deeply woven into the reef that only the shape of the seafloor reveals their outline. The reefs act as a kind of archive, preserving in stone and coral what the sea might otherwise have scattered. Divers who visit these sites often describe a quiet stillness there, a sense of time having gently paused. The coral continues its slow, patient work, growing year by year, drawing the past into the fabric of the living sea. Beneath the quiet surface of the Bermuda Triangle, the seafloor holds a secret that scientists have only recently begun to understand. Vast deposits of methane hydrate lie frozen within the sediment, locked in a crystalline lattice of ice and gas. These formations look something like ordinary ice, yet within them, molecules of methane are held perfectly still, patient and undisturbed. The Atlantic Ocean basin beneath this region is particularly rich in organic matter, slowly decomposing over millions of quiet years. As that organic material breaks down, methane gas gradually accumulates, pressing gently upward through the layers of rock and clay. When water temperatures shift or pressure changes slightly, those frozen hydrate structures can begin to quietly release their stored gas. Columns of methane bubbles drift upward through hundreds of meters of still, deep water, rising toward the surface in slow procession. Some researchers have proposed that very large releases of methane could reduce the density of seawater in localized areas. Water made less dense by rising gas behaves differently, and the question of whether ships might be affected has been studied with careful attention. Laboratory experiments have recreated the conditions on a small scale, watching how objects float differently when gas is introduced below them. The seafloor of the Bermuda Triangle region is not flat, but gently uneven, shaped by ancient underwater landslides and slow geological movement. Those ancient landslides may themselves have triggered sudden releases of methane, sending quiet plumes rising through the water column long ago. Today, the methane seeps of this region continue their slow, unhurried work, a gentle exhale from the earth beneath the waves. Beneath the surface of the Bermuda Triangle, vast rivers of water move silently through the deep ocean without a sound. These are the invisible currents, ancient and patient, shaped by the spin of the earth itself over millions of years. The Gulf Stream is perhaps the most powerful of them, a warm river within the ocean rushing northward along the eastern coast of Florida. At its core, the Gulf Stream carries water moving at nearly 5 miles per hour, far faster than most people would ever imagine the sea could flow. Where this warm river meets cooler Atlantic waters, long soft eddies form and dissolve, slowly spinning for weeks or even months. These rotating pockets of water can be hundreds of miles wide, yet from a ship on the surface they are nearly impossible to notice. Sailors crossing the triangle have long reported strange compass behavior, and some scientists believe shifting current boundaries may play a subtle role. The currents here also carry enormous amounts of heat, quietly moderating the climate of the entire North Atlantic region far to the east. In places where these currents rise from the deep, they bring cold nutrient-rich water upward, feeding blooms of tiny life near the surface. Beneath the triangle, the seafloor is anything but flat, with ridges and trenches that quietly deflect and shape these underwater rivers. In time, oceanographers began mapping these currents using drifting buoys, which slowly traced invisible highways across the sea over years and years. Each buoy told a quiet story, drifting southward and then looping gently back, carried by forces older than any ship that ever sailed. And so the triangle's invisible currents continue their slow and ancient work, flowing on beneath the waves as the world above rests in stillness. In January of 1948, a large British aircraft called the Star Tiger lifted quietly into the night sky above the Azores, bound for Bermuda. The Tudor 4 was a proud and capable machine, carrying 25 passengers and crew across the wide Atlantic on a well-traveled route. Weather that evening was moderate, the winds a little stronger than expected, but nothing to cause particular alarm among experienced aviators. The flight path carried the Star Tiger southwestward, following the ancient corridor that ships and aircraft had used for decades. Somewhere over the dark ocean, the aircraft sent its last routine radio message, calm and unremarkable, just a position report. After that final transmission, the Star Tiger simply faded from all contact, leaving only the open sea beneath a quiet sky. Search aircraft flew out the next morning, sweeping great arcs of ocean where the plane should have been, finding nothing at all. The sea offered no wreckage, no oil slick, no debris of any kind, only the quiet movement of water in every direction. British investigators spent months carefully examining every detail of the flight, the weather, the fuel, the radio logs, and the aircraft itself. They considered the strong headwinds, the possibility that fuel ran lower than calculated, and the long hours the crew had already been flying. The official inquiry concluded, with quiet honesty, that the cause of the loss could not be determined from the evidence available. And so the Star Tiger passed into history, remembered not for drama, but for the gentle mystery of a journey that simply did not arrive. Somewhere beneath those patient waters, perhaps, the answer rests quietly, undisturbed, as the ocean moves slowly on without revealing it. Far out in the Atlantic Ocean, between the islands of the Caribbean and the coast of Portugal, lies a very unusual stretch of sea. It is called the Sargasso Sea, and it is the only sea on Earth defined entirely by ocean currents rather than by any coastline. For great currents encircle it slowly: the Gulf Stream, the North Atlantic Current, the Canary Current, and the North Atlantic Equatorial Current. Within this gentle ring of moving water, the Sargasso Sea rests almost perfectly still, calm and unhurried. And floating quietly across its surface, carried by almost no wind, drifts a vast meadow of golden-brown seaweed called sargassum. Sailors in the age of exploration would gaze upon these drifting weeds with a sense of quiet wonder, unsure of what to make of them. Some early maps marked this region with cautious notes, whispering of a sea where ships might slow and the world might seem to pause. The sargassum itself is remarkable. It spends its entire life floating free, reproducing by simply breaking apart and drifting on. Tiny air bladders keep each frond buoyant, little golden spheres that have kept this seaweed aloft across the open ocean for millions of years. Beneath the mats of weed, a world of small creatures finds shelter: seahorses, tiny crabs, and juvenile fish resting in the gentle shade. The Sargasso Sea receives little rain, loses much water to evaporation, and so its water is noticeably salter and clearer than the ocean around it. This unusual clarity gives it a deep, luminous blue that travelers have described as some of the most striking water on the planet. And so the Sargasso Sea drifts on, quietly, at the heart of the Bermuda Triangle, a slow green garden adrift in the middle of the deep blue world. In the autumn of 1872, a brigantine called the Mary Celeste set sail from New York Harbor, bound for Genoa, Italy. She carried a cargo of industrial alcohol in her hold, along with a crew of 10 people and the captain's wife and young daughter. The voyage began without incident, the ship moving steadily eastward across the North Atlantic through early November. A month later, on December 4th, a Canadian brigantine named the Dei Grazia spotted an unfamiliar vessel drifting erratically nearby. The captain of the Dei Grazia sent a small boarding party across to investigate the quiet, seemingly listless ship. When the men climbed aboard the Mary Celeste, they found the ship entirely deserted, with not a single soul anywhere on deck or below. The ship's lifeboat was gone, suggesting the crew had departed deliberately at some point during the crossing. Below deck, the crew's belongings remained largely untouched, with clothing still folded and personal items resting quietly in their places. The ship's log contained routine entries up through November 25th, with no mention of danger or any unusual event. The cargo of alcohol appeared largely intact, though investigators later noted that some barrels had been opened and found empty. Theories have circulated for well over a century, ranging from waterspout encounters to the shifting vapors of the alcohol cargo causing alarm. The most measured explanation, held by many maritime historians, is that fear of an explosion led the crew to take briefly to the lifeboat. Whatever the reason, the Mary Celeste drifted on through those quiet winter waters, a ship perfectly intact, waiting in the stillness. Beneath the warm, shallow waters of the Bahamas, ocean floor opens into vast circular chambers of breathtaking stillness. These formations are called blue holes, ancient passages carved by rainwater through limestone thousands of years ago. The most famous of them, the Great Blue Hole off Belize, stretches 300 meters across and plunges more than 150 meters deep. From the surface, its color shifts from the bright turquoise of the surrounding reef to a serene, deep cobalt at its center. Inside the Bermuda Triangle region, dozens of smaller blue holes and submerged cave systems quietly dot the seafloor. Scientists believe these caves were open-air caverns during the last ice age, when sea levels sat far lower than they do today. As glaciers melted and oceans rose, the caverns slowly flooded, preserving within them a kind of frozen record of another age. Researchers exploring Dean's Blue Hole in the Bahamas have found layered sediments that tell a quiet story of climate across millennia. The deeper waters of these holes hold almost no oxygen, preserving organic material and ancient pollen in extraordinary detail. Stalactites still hang from the ceilings of some submerged caves, impossible to form underwater, silent proof the caves were once dry. Divers who descend into these blue holes describe a profound quiet, a world apart from the busy reef just above. Ocean currents flowing through the cave passages carry nutrients that attract rich communities of sea life to the cave openings. These ancient, flooded chambers rest in patient silence beneath the waves, their stone walls holding the memory of 10,000 years. Beneath the surface of the Bermuda Triangle, the Earth's magnetic field shifts in subtle, almost imperceptible ways. For centuries, sailors noticed their compass needles drifting just slightly from true north, a quiet mystery written in iron and magnetite. The Earth's magnetic poles are not fixed in place, they wander slowly across the planet's surface over decades and centuries. In certain ocean regions, the difference between magnetic north and true north, called magnetic declination, can be unusually pronounced. The Bermuda Triangle sits in a corridor where this declination has historically hovered near zero, meaning compasses once pointed toward both norths simultaneously. Early explorers, including Christopher Columbus on his 1492 voyage, recorded unsettling compass behavior passing through these very waters. Columbus wrote in his log of flames flickering on the water and a compass needle swinging without cause, though he pressed onward calmly. Geologists have found that the seafloor beneath the triangle contains bands of basalt rich in magnetite, an iron mineral with its own magnetic signature. These mineral bands create local magnetic anomalies, small pockets where the field strengthens or weakens in ways that can confuse modern instruments. Scientists have mapped these anomalies using sensitive magnetometers towed slowly behind research vessels across the region. The data reveals a patchwork of magnetic variation beneath the waves, a quiet mosaic invisible to the eye but measurable by science. Over time, as the magnetic pole continues its gradual migration northward, these local anomalies will slowly shift and change in character. And so the triangle's quiet magnetic story continues to evolve, written not in legends, but in the patient language of the Earth itself. In the spring of 1955, a small Tudor wooden vessel set out for Miami under clear skies, carrying 6 crew members and a routine cargo of supplies. The Tudor was a modest working boat, weathered and familiar to the waters between Florida and the Bahamas, a route its captain had sailed many times before. For the first 2 days, radio contact was normal, the crew reporting calm conditions and steady progress through gentle Atlantic swells. On the 3rd morning, scheduled radio contact came and went in silence, the frequency carrying only the soft static of an empty channel. The Coast Guard station in Miami logged the missed contact and began a methodical search of the Tudor's last known course. Search planes flew low over the Bahama banks, where the water is so shallow and clear that a submerged vessel might easily be spotted from the air. They found nothing, no debris field, no oil slick, no life ring drifting on the surface, only the quiet, unbroken sea. Investigators later noted that the Tudor had carried no distress flare, an oversight that was sadly common among small working vessels of that era. Weather records for that period showed nothing unusual, no storm, no squall, no wind strong enough to overwhelm a seaworthy craft. Some researchers have suggested that a rogue wave, invisible to weather instruments of the time, may have risen suddenly and passed without witness. Rogue waves, though rare, were not yet understood by science in the 1950s, and many ships lost without explanation may owe their fate to these brief, enormous walls of water. The names of the 6 crew members were recorded in the Coast Guard registry and then, slowly, absorbed into the long, quiet list of those who did not return. The sea, patient and unhurried, keeps its records in its own way, and the story of the Tudor rests there now, gently held in deep Atlantic water. Long before modern maps were drawn, ancient storytellers spoke of a magnificent civilization that once rose from the sea. Plato, the Greek philosopher writing around 360 BCE, described a great island empire he called Atlantis, powerful and prosperous beyond measure. In his dialogues, Plato placed Atlantis beyond the Pillars of Hercules, in the vast open waters of the Atlantic Ocean. He described grand harbors, rings of water and land, and a people who had built something extraordinary over many generations. Slowly, over centuries, Plato's tale was read and reread, each generation finding new meaning in the story of the lost island. In time, explorers and scholars began to wonder whether Atlantis might have been a real place, submerged beneath the waves long ago. The Bermuda Triangle, sitting in the western Atlantic, was a natural candidate in the minds of those who wanted Atlantis to be real. Some writers in the 20th century suggested that Atlantean crystals or energy devices might still rest on the ocean floor below. In 1968, divers near Bimini Island in the Bahamas discovered an arrangement of large flat limestone blocks beneath shallow water. This formation, quietly known as the Bimini Road, stretches roughly half a mile and sparked decades of gentle curiosity and study. Geologists who studied the site concluded that the blocks were most likely natural beach rock, shaped by centuries of tide and erosion. Even so, the discovery reminded people how little of the ocean floor we have carefully and quietly explored. Atlantis remains a story that rests gently at the edge of history and imagination, inviting quiet wonder rather than definite answers. Beneath the still surface of the Atlantic, the ocean floor drops away into regions that human eyes have never seen. The Bermuda Triangle sits above one of the most geologically complex stretches of the western Atlantic basin. Here, the seafloor descends in long, gradual slopes called continental margins, reaching depths of 4,000 meters or more. The Puerto Rico Trench lies just to the south, the deepest point in the entire Atlantic Ocean, nearly 9,000 meters below the surface. Scientists have mapped much of this trench from research vessels on the surface, using sound waves that travel down and echo back. The resulting maps reveal a landscape of ridges, valleys, and ancient volcanic formations stretching for hundreds of kilometers. Yet despite these maps, fewer than 20% of the global ocean floor has been directly observed by any camera or submersible. In the deep water column, temperatures hover just above freezing, and the pressure becomes immense beyond any ordinary measure. Life still finds a way in these quiet depths, with slow-moving creatures drifting through water that has not seen sunlight in centuries. Ancient sediment layers on the trench floor hold a quiet record of thousands of years of history, undisturbed by currents above. Some geological features near the Bermuda Triangle remain unmapped at high resolution, their exact contours still waiting to be understood. Oceanographers continue their slow, patient work, returning season after season to gather a little more knowledge from these immense, quiet depths. And so the deep places beneath the triangle rest in their patient stillness, holding their quiet secrets in the soft, undisturbed dark of the sea. Along the western edge of the Atlantic, thick banks of fog sometimes rise from the warm water with a quietness that feels almost deliberate. The Bermuda Triangle sits at a crossroads where the warm Gulf Stream meets cooler surface air, a meeting that encourages moisture to gather and linger. Warm water releases heat gently upward, and when that rising warmth encounters cooler air above, the invisible moisture condenses into a soft, pale veil. Sailors who have crossed these waters for centuries have written of fog appearing between one watch and the next, the horizon simply dissolving away. In calmer conditions, the fog can settle so completely that the water and sky become one continuous, featureless white. Navigation before modern instruments relied on the stars and the horizon line, and fog erased both with a kind of gentle thoroughness. The Florida Straits, where the Gulf Stream flows swiftest, are especially prone to these sudden whitened mornings, known among local fishermen simply as the milk. Meteorologists understand fog as a form of low cloud, a layer of tiny water droplets suspended just above the surface, ordinary in its physics. What makes the triangle's fog unusual is how rapidly it can form, sometimes within 20 minutes of clear and open sky. Coast Guard records from the 20th century include many accounts of vessels reporting sudden zero visibility without any forecasted weather event. Modern research suggests that the Gulf Stream's warmth, combined with seasonal shifts in air temperature, creates conditions ripe for fog with very little warning. Aircraft pilots, too, have described entering these fog banks and finding the world reduced to a soft, even brightness with no horizon to orient by. And slowly, as the morning sun climbs higher and warms the surface, the fog thins, and the blue Atlantic reappears, still and unhurried, as though nothing had changed. Off the western coast of the Bahamas, a shallow bank of warm turquoise water stretches quietly beneath the open sky. This is the island of Bimini, a slender strip of land surrounded by some of the clearest, calmest seas in the Atlantic world. For centuries, local fishermen knew these waters well, navigating by the color of the sea floor and the gentle pull of warm currents. In 1968, a diver exploring just below the surface made a quiet and unexpected discovery beneath the sand. Beneath only a few feet of water lay a long, orderly row of large flat limestone blocks, stretching in a graceful curved line. The stones, some weighing several tons, were remarkably uniform in size and arranged with a regularity that seemed almost deliberate. This submerged formation became known as the Bimini Road, and it quietly captured the imagination of researchers and dreamers alike. Some early enthusiasts believed the stones might be the remnant of a vanished civilization, perhaps the legendary Atlantis spoken of by Plato. Geologists who studied the formation carefully found that the limestone matched the natural bedrock of the Bahamian shelf beneath. Over many thousands of years, the sea level rose gradually, and what was once dry coastal land slipped slowly beneath the water. The regularity of the blocks, researchers concluded, is a natural result of the way limestone fractures along straight geometric lines. Still, the Bimini Road remains a peaceful and beautiful sight, visited by divers who float slowly above its ancient stones. Whatever its true origin, this quiet underwater path invites the mind to wander gently through the long, unhurried story of the sea. High above the waters of the Bermuda Triangle, a rare and quiet phenomenon drifts through the atmosphere on certain still mornings. Hexagonal clouds, sometimes stretching 40 miles across, form in loose clusters over the western Atlantic near the Bahamas. Inside these cloud formations, microbursts of air descend rapidly toward the sea, carrying enormous force within their calm-looking exteriors. Researchers studying weather patterns above the triangle noticed these formations behave differently from ordinary storm clouds. The air within a microburst can accelerate downward at speeds exceeding 100 miles per hour, invisible from the outside. When a small aircraft enters such a column of descending air, it can lose altitude faster than its instruments can register. The ocean below remains deceptively smooth, offering no visible warning of what stirs in the air above it. Scientists from Princeton and the American Meteorological Society documented these hexagonal cells using satellite imagery in the early 2000s. Similar cloud formations have been observed over the North Sea and the coast of Norway, suggesting a broader atmospheric pattern. The Bahamas Bank, a vast shallow plateau beneath the triangle's western edge, may warm the air just enough to trigger these formations. Early aviators flying over the triangle in the 1940s and 1950s had no way to detect such weather events ahead of time. Modern weather radar and satellite tracking have made it far easier for pilots to navigate around these unusual cloud clusters. And so the sky above the triangle, once full of quiet unknowns, slowly yields its secrets to patient and careful observation.